All around the world, patients receive medicine in order to alleviate or cure their health conditions. They rely on them to work, but oftentimes they don't because the medicines are fake. And oftentimes, it is almost impossible to tell the difference. Counterfeit medicines are a huge business, estimated to cost the global economy $75 billion a year, and the industry is growing rapidly. In countries like the United States, fake medicines account for up to 3% of all medicines on the market. This might mean that medicine a cancer patient is relying on to fight their disease is actually doing nothing, or worse. The current situation is more dreadful in the developing world. If you are a patient in Nigeria, Africa's largest pharmaceutical market, you are 2/3 more likely to get a fake pill than a real one. That means that for every 3 people going to the pharmacy to get life-saving malaria medicine, only 1 of them is actually getting correct medicine. Techniques for testing pharmaceuticals exist, but are either too expensive and time-consuming, like a lab analysis, or are too untrustworthy or easily tricked by criminal counterfeiters. With an estimated 700,000 people dying each year from fake malaria and tuberculosis medicines alone, something radically new and powerful is needed to fight against the counterfeiters. We believe we have such a solution. EP Devices has developed powerful, lab-quality, analytical techniques to provide robust lab analysis in 3 seconds with a smartphone-sized device. Not only that, but anyone can use them. If you can press a button, you can initiate an exact and a sophisticated analysis of any pharmaceutical and get a simple pass-fail answer back. This means that the only kind of analysis counterfeiters cannot trick, a composite molecular fingerprint, is now accessible to non-scientists in real time. How does it work? The device uses a safe optical beam to probe molecules that make up the sample, then uses advanced mathematical and data processing techniques to build a full fingerprint. This takes place only if the sample is verified, as in an authentic pharmaceutical factory by a quality control specialist. In the field, as in a clinic in the developing world, a non-specialist user could harmlessly test a medicine. If a tested sample is or is not an exact atomic fingerprint match, the user will be alerted with a simple pass-fail color-coded response. This means that the more devices we can get into the hands of people, the more counterfeit medicine can be caught before they get to the patients. Authorities can also use this to test samples, giving them the power to perform actionable analysis on the spot, instead of sending off a sample to a lab while hoping the criminal doesn't run away. This sounds great, but does it actually work? We have successfully tested this technology on over 12,000 pharmaceutical samples with no false positives or negatives. We are ready to take this out of the lab and into the most challenging environment we can think of, with the highest potential for humanitarian impact. Please consider contributing to this effort and spreading the word.